We're going to discuss about hypothesis. We are going to talk about Z-test in this video. So before starting Z-test, let us understand what is hypothesis. Hypothesis is a statement which has not been proved yet. So we can give one example. Say that if we are saying that IQ of girl is better than IQ of the boys, and if we have not tested it, then it is a hypothesis. So we are not putting any question mark, but we are saying hypothesis of girl is better than or more than IQs of boys. IQ of girl is more than IQs of boys. Or we can say that IT professionals are getting more average salary of IT professional of Bangalore is getting more average salary than maybe IT professionals of Kolkata. So if we have not proved it and it is a statement, we can say that it is the and it is a hypothesis. And then based on the data, whatever we are going to get, we can find it out whether whatever assumption we are having that is correct or not. So what are the processes to do hypothesis testing? What are different steps in doing hypothesis testing? What is one tail, two tail test? What is significance level? What is confidence level? All those things we are going to talk in this video today. So let us start. Let me share my screen with all of you. So what is hypothesis? It is an educated guess or prediction about the relationship between two variables that can be tested with observable evidence. Hypothesis works as a blueprint for your investigation. So it is a starting point for further investigation or testing. And the goal is to test the idea, but not to prove it. So there are 5 steps whenever we go for testing of the hypothesis. The first step is we are required to formulate null and alternate hypothesis. Then second step is we are going to set the level of significance. We will find it out the tail, that is one tail test or two tail test. What is critical value? What is degree of freedom if it is say maybe applicable? In Z test degree of freedom is not applicable. In T test it is applicable when we have got sample size less than 30. Then we will calculate the test statistics. We will locate whether whatever value we have calculated, it goes in the area of acceptance or rejection, and based on that we will basically accept the null hypothesis or we will go for alternate hypothesis and then drawing the inferences. So these are 5 steps whenever we are going for test the hypothesis. Now let us go in more details about it, like what is null hypothesis, what is alternate hypothesis. So I'm going to explain everything. So how to write null hypothesis? We will write null hypothesis like H0. This is how we write null hypothesis, and alternate hypothesis we write as H alpha, H1, whatever you want. Okay, so null hypothesis is denoted by H0 or H0, whatever you say, and this is alternate hypothesis. So let us make one example for hypothesis. If we say that a machine which is dispensing detergent in the say a poly bag, and it is set to dispense 500-gram detergent in the poly bag. Fine. So what is my null hypothesis? Null hypothesis says that on the average, that is mu, value of mu is how much? 500 gram. Okay, so on the average, every poly bag should contain 500 gram of detergent, right? That is the null hypothesis. So how to identify what is null hypothesis, what is alternate hypothesis? Listen carefully. Null hypothesis always says it is equal to something, or it says there is no difference, there is no relationship, etc. So null hypothesis says it is always equal, or between two different things there is no difference, there is no relationship, etc. So right now I am saying mu equal to 500 gram. It means the packets of detergent powder, because we are saying that we are selling 500 gram of detergent powder. So all packets should contain 500 gram of detergent. So that is on the average my null hypothesis. It means we are saying 500 and there is no difference in the packet, whatever we are selling. So we told 500 gram and we are giving 500 gram. Now, suppose that the company who are making this detergent and they want to cheat the customer. In that case, what they can do? They can fill less than 500 gram of detergent, right? They can fill less than 500 gram of detergent powder. So whatever you want to prove, that will always go in the alternate hypothesis. So listen again, whatever you want to prove, it will always go in the alternate hypothesis. So what we want to prove? We want to prove that mu is less than 500 gram. This can be one case, right? That we are telling that we are giving 500, but somehow company wants to cheat, and that's why they are giving less than 500 gram. That can be one case. So this is what case 1. I'm writing C1. Sometime we can have another case also. I don't know when this will be applicable. H mu, we are telling that we are giving 500 gram of detergent. So my null hypothesis says that amount of detergent in the poly bag is 500 gram. But my alternate hypothesis can be mu greater than 500 gram. This can also be a case. So suppose something is improved. Say the new medicine has improve the condition of the people. So we will say that that place it is going to come greater than whatever value. So say that maybe after taking this medicine, 6 months people will not get cough and cold. So earlier less than 6 months, less than equal to 6 months, now greater than. So that could be my another case, that company is giving little extra detergent. So that is greater than 500 gram. That is also possible. Like we want to prove that company is giving more than 500 gram of say what detergent powder. We can have one more case. Mu, null hypothesis mu equal to 500. That remains my null hypothesis. My alternate hypothesis can be, see, the machine which is dispensing the detergent, that has got some problem. So sometime it is dispensing little more, sometime it is dispensing little less. So we don't know it is more or less. So my third case can be what? It is not equal to 500. So company would like to check whether the machine is working properly or not. So they will find that sometime the amount of detergent is less than 500 grams, sometime it is a little more, sometime it is equal to 500. So these three cases we can have. So we can write hypothesis something like that. So whatever we want to prove, that is always goes in the what? Alternate hypothesis. So based on our problem, our alternate hypothesis can be any of these things. And our null hypothesis can also be mu less than equal to, greater than equal to, or equal to. That sign can also come, depend on what type of problem we are going to solve. These two cases where we want to prove it is less than or greater than, it is known as what? One-tailed test. It is known as one-tailed test, right? And here because my answer can be more also, less also, we don't know. But here we are interested in getting less value. Here we are interested in getting more value. So either left side tailed or right side tailed. So it is one tail test, but this is two tail test because my answer can lies on any side of the tail. So this is known as what? One tail test or two tail test. So whenever in your alternate hypothesis it comes, it is not equal to something, we will go for what? We will go for two tail test. Otherwise it is left tail or right tail test. Whenever less than sign is there, it is left tail test, and whenever greater than sign is there, we are talking about alternate hypothesis, it is what? Right tailed test. So whenever we are going to say what test the hypothesis, we are going to make this area normal curve, okay, and then we have got critical point. I will again explain what is critical point in the next slide, but just right now understand it. So say this point where I draw the line is the critical point, and say the value of critical point is 1.645. How this value is going to come, I will explain in a while. Just now understand that what it is. This is one tail test, and I am going to talk about right hand tail test. So my critical point is coming 1.645, and when we calculate value of z, suppose z is coming 2 point something 68. Okay, this we calculated. Now this area, which is before this critical point, okay, which is before this critical point, I am setting it. If my value z lies in this side, this is known as region of acceptance. Region of acceptance. And we are talking about null hypothesis. Okay. If my z value comes in this side, our null hypothesis is going to get accepted. But if we calculate z value and if it goes this side, other side, next to the critical region, this is known as what? Region of rejection. Region of rejection. So if my value is going to go next to the critical point, then we are going to reject the null hypothesis and my alternate hypothesis is going to get accepted. So in this example, what I told just now, that z we are getting, suppose we got value of z 2.68, which is more than this. So it means z comes this side. So H0 is going to get, H0 is what? We will fail to accept, null hypothesis. So in this case, we fail to accept null hypothesis. It means we are going to accept what? Alternate hypothesis. This is how we are going to basically draw the conclusion and we write our interpretation. How to do it? So the formula for z test is, I'm writing here, z equal to x bar minus mu divided by standard deviation by root n. Okay, where what these values are? X bar is sample mean. X bar is sample mean. Okay, mu is population mean, which I wrote in the my alternate null hypothesis. Mu is what? Population mean. Population mean. This is standard deviation of the sample, and n is number of samples. So if we put all these things in the formula, calculate z value, find the critical point, we are going to get answer, and then we are going to write our interpretation. So this is the process to go for hypothesis testing. So let us see what is the process of hypothesis testing. So we'll go here, 1 second. There are 5 steps in hypothesis testing. So first step, what it talks, formulate null and alternate hypothesis. So based on your question, write what is H0, mu equal to something will be given. What is your alternate hypothesis? So you have to find out mu. The next talks about setting up level of significance for the test, tail of the test. So what significance talks about level of significance? If we talk about significance, it is 1%, 5%, and 10%. Level of significance is what? 1%, 5%, and 10%. Level of significance tells how much error we can tolerate. So if level of significance, that is error 1%, it means how much confidence we are? We are 99% confident here. 1% error, 99% confident we are. 5% level of significance, 95% confident we are that our null hypothesis is selected correctly. And this is what 90% confident we are. So for level of significance 1%, 5%, and 10% based on one tail or two tail test, we have got some critical point value. So I told here one tail or two tail test, we have got these critical point values. So if one tail test and level of significance is 1%, the critical point will become 2.33. For two tail test at 1%, 2.58. If nothing is given in the problem, generally we go for with 95% of confidence, that is 5% level of significance. So for one tail test it is 1.645, and for two tail test the value is 1.96, right? For 10% it is 1.28, and for two tail test it is for 10% it is going to be 1.645. So this is the critical point for Z test. I'm not talking about any other test right now, because for all different tests we have got Z test, T test, chi-square, and ANOVA test. So for all of them these values differs. So whenever I will be talking about those things, I will tell you how to get the critical point for those values. Right now for Z test, it is fixed for 1%, 5%, and 10%, and these are these values. If you are going to solve problem in your exam, what happens? These values generally is provided, or table will be given to you. If you are solving your business related problem, you can search these values in the Google, or maybe any stats book, it will be given over there. So now if you have to solve some problem with this, what to do, how to go ahead. So let us see here one of the questions. Suppose an airline claims that its flights are consistently on time with an average delay of at most 15 minutes. So they are telling that my flight, the air company, airline claiming that the mu is 15 minute. It means they are telling that the average delay of all their flights is 15 minute. So they are telling that my null hypothesis is mu equal to 15 minute. Doubting the consistency part of claim, a disgruntled traveler calculates the delays for his next 50 flights. So sample here given. So n is given 50, mu is given 15 minutes. Okay. The average delay for those 40 flights, not 50, na? So he talked about 40 flights. Yeah. So let me make it correct. Erasure, and yeah. So he talks about 40 flights. So n equal to how much given? 40, and average delay he gets 22 minutes. So X bar he is getting 22 minutes, right? And standard deviation of 15 minutes. Flights with 22 and standard deviation 15. So standard deviation is 15. Yeah. So is the traveler disputing the claim about average? So the airline says that on the average delay is 15. So alternate hypothesis mu will become greater than, because that's what he wants to prove, that flight is much more delayed. Now we got our null hypothesis, alternate hypothesis. When nothing is given, we will take level of significance, that is alpha equal to 5%. And we are going for greater than. So it is what test? It is right-tailed test, one-tailed right-tailed test. So for this, what is critical point? So critical point, let us go to this 5% one-tailed test. It is 1.645. So how much it is? 1.645. So we got our null hypothesis done. We have got our critical point, find it out based on level of significance. So now let us solve the problem, and let us check that what is there. So this is the normal distribution. Critical point is given how much? 1.645. My level of rejection and acceptance I am going to shed here. So this area is region of acceptance, region of acceptance, acceptance. So my null hypothesis will get accepted if my z value will come less than 1.645, and this is what? Region of rejection, region of rejection. So let us put everything in the formula. The formula was z equal to x bar minus mu divided by standard deviation by root n. X bar is given how much? 22 minus 15 divided by 15 by how much? Root 40, right? So 22 minus 15, we are getting 7 by 15, and root 40, it is going to become 6 point something. Let me take a calculator and we'll find out what is value of root 40. So under root 40 equal to, it is 6.32. So into 6.32 divided by 15 by 6.32. So that is what? Equal to 7 into 15 multiplied by 6.32. Correct? Yeah. So we will calculate it and check it how much we are getting. Calculator. So we have got how much? 7 into 6.32 equal to 44 point something divided by 15 equal to 2.94. So we're getting close to 2.94. So Z calculated value, what we calculated right now, it goes in the region of what? Rejection. You can see it clearly. It goes in the region of rejection, right? So 2.94 comes in this area, right? So since Z calculated is greater than critical point, so we fail to accept, we fail to accept null hypothesis H0. So traveler's claim is true. Traveler's claim is true. It means the flight is late. Flight is late, delayed more than 15 minutes. That's what we are talking. Fine. So see that here 40 flights, 22-minute delay with a standard deviation of 15 he got. We put everything in this equation and we are going to get this 2.94. Since 2.94 is not coming, it is not less than this critical point, but it is more than critical point. That's why we are failing to accept null hypothesis and we accept the alternate hypothesis. Fine. So this is how we are calculating Z test. Do more practice and let me know if you understood it or not. In case of any doubt, you can write the comments and I'll come back to I'll come back on your comments whenever I'm going to get time. Thanks and happy learning.